Hi, Honors Algebra 2 students. In this lesson, we're going to explore a way of solving systems of equations with using something called row reduced echelon form, or RREF. Before we get to that, though, we're going to do some preliminary work. So in these first four examples, it says solve each system using substitution, linear combination, or sometimes it's referred to as linear elimination, or inverse matrix. But if we take a look at these, we're going to be able to go through and solve them pretty quickly. In fact, I already have them written out, so I can just talk through them. In example number 1, if you notice, we have 0 y's in the first equation and 0 x's in the second equation. And so literally, x is equal to -2 and y is equal to 3. And that indeed is our ordered pair, -2, 3. If I take a look at example 2 and I add the two equations together, notice that my x terms go away, my y terms go away. So on the left-hand side of the equation, I have 0, and on the right-hand side, I have 10. If my variables go away and I have a false statement, such as 0 equals 10, then my final answer is no solution. You can either write the words out or you can use the mathematical representation of no solution. In the third example, my second equation is y equals something, so if I take that something, the 4x minus 1, and substitute it in for y in the first equation, and go through and distribute my negative sign, I will end up with the variables going away and the true statement of 1 equals 1. And so we've talked about how we have to fine-tune our final answer in a scenario like this for systems of equations. It is an infinite number of solutions or infinitely many solutions on the line, and specifically in this case, our line is y equals 4x minus 1. Or you could use this version of the equation of the line. And then finally, in number 4, we have a 3 by 3 system. But again, if you notice in the first equation in that system, we have 0y and 0z. In the second equation in the system, we have 0x and 0z, and then in the third equation in the system, we have 0x and 0y. So literally, notice we have 1's on the diagonal. 1x is equal to 3, 1y is equal to -4, and 1z is equal to 5. So we have the ordered triple, 3, -4, 5. Those are 4 examples that we can do very, very quickly, all right, and they're going to lead in to something we're going to do in just a moment. All right, in the next part of the lesson, we're going to go through this example with this system of equations, and we're going to show how to row reduce it. And then this is more or less, I tell students, what your calculator is going to be doing with the RREF functionality that we're going to take advantage of on it. And basically it corresponds to solving the same system by linear elimination or combination. So I usually just step through this and I say it's for your reference. You'll see what we're going to do with our specific examples once we get to the next page of notes. But let's go through the 4 steps that are listed here, just so you can kind of see behind the scenes what's going on. So the first step says multiply row 1 by -2 and add it to row 2. All right, so we're going to take row 1, like it says, we're going to multiply it by -2. We're then going to take the second equation or the second row and write it as is, and then we're going to add it together, so to speak. So our x terms go away. I put the 0x there just for emphasis, and then we get 5y is equal to 10. And I should back up and say over here for just a moment, this column right here represents from the original system what the coefficients were for the x's. The second column represents what the coefficients were for the y's from the original system. And then this third column represents the constants that were in the original system. All right, so what you see right here, you see row 1 being repeated, and you see the result of doing all of this being written in the second row right here. It's just carried over. All right, step 2 says multiply row 2 by a fifth. So literally this was row 2 and I multiplied it by a fifth. Or in other words, I took this and I multiplied it by a fifth and I got 0x plus 1y is equal to 2. So we're going to keep the same row in there for the first row as we originally did, and then the result of multiplying row 2 by a fifth is now written right here. The third step says add row 2 to row 1. So I've got row 1, again I've got row 1 from up here. I'm going to take this new row 2 right here and I'm going to add them together. And I'm going to put the result of that, so I get x and then 0y for emphasis is equal to -1. I'm going to put the result of that right here. So add row 2 to row 1 and put the result back in row 1. And I'm going to leave row 2 written as is from the prior step. All right, then how that's going to help us is, remember that these represent the coefficients for the x's, these represent the coefficients for the y's, and these represent the constants. So if I interpret this answer, this is saying 1x is equal to -1 and 1y is equal to 2. And that is written as an ordered pair as -1, 2. All right, now again, all of this, bottom half of the first page of notes, is just for your reference to have you kind of see behind the scenes when your calculator is row reducing, what process it's going through, but it follows the steps involved in linear combination. And we are truly going to use our calculator to let it do this for us. We are not going to write it out side by side, but this part is here for your reference if you want to know behind the scenes what your calculator is doing for you and the approach that it's taking. All right, now before we dive into new examples, this is the system from the prior page, and this is what it's going to look like to use our calculator. So in other words, we're going to enter our data into a matrix, for example, matrix A, using the same process that you would have learned prior to this lesson, making sure that our matrix dimensions in this case are going to be 2 rows by 3 columns. All right, and what we're going to put in matrix A would be this part right here. So in other words, if we've got 1x, so 1 goes right here, minus 1y, so -1. In other words, the coefficient for the x variable, the coefficient for the y variable, is equal to -3. So our constant comes down. And then for the second row in our matrix, we're going to take 2x, so we're going to put a 2 right here, 3y, we're going to put a 3 right here, and then our constant is 4, so we'll put a 4 right here. This column, again, contains the coefficients for the x's. This column contains the coefficient for the y's, and this column contains the constants. And we're going to put them all in one matrix. So you would be entering on your calculator this information, this data, into matrix A. Then you would go back to the main screen, the home screen, and you would do RREF on that matrix, wherever you stored it, like matrix A. And RREF is found, you have to go to the matrix menu, then you arrow across at the top to the math option, and then you actually arrow down to option B, and it says RREF, or actually you could arrow up to option B. It's a little quicker to get there that way. But again, the matrix menu, which you're familiar with, go to the math option, which is at the top, and then go to option B for RREF. That will bring the RREF back to the main screen, and then you can enter the name of the matrix, for instance, matrix A, where you entered this information, and then you hit enter, and this is what it returns on your screen. And then we just need to learn how to interpret this. So sometimes I'll tell students, I put a little squiggly line right here, okay, to separate what are going to be coefficients and what are going to be constants. So here's how I interpret this matrix. 1x is equal to -1, because I've got 0 y's, and here 1y is equal to 2, because I've got 0 x's. So that indeed is my final answer ordered pair. All right, so what we're going to do in the next examples, I'm going to show the setup for using row reduced echelon form, RREF. You will be using your calculator, though, to get your final answers, and I'm going to be showing the work that you need to write down and talking through what you need to do on your calculator. I would encourage you to pause where I say, okay, now go enter this on your calculator, and actually enter the information, and then once you've done that and you've gotten your answer, proceed with the video to see if you got your answer correct. The other thing I will say is that in class, if you're not able to follow along how to actually enter these on your calculator, make sure in class you ask your teacher so that your teacher can go through the details on the calculator more interactively than what I can do in the video. All right, so let's get started. The first thing we're going to do is we're going to create our matrix. And so to do that, we're going to create them in the same format that we had written above. So I'm going to take a matrix, and I'm going to put my constants for the first row, which would be negative, or my coefficients, -6, +5, and then my constant of 4. And then in the second row, I've got a coefficient of 7, a coefficient of -10, and a constant of -8. And I'm going to put all of that in one matrix. So when you enter this on your calculator, you should be entering a 2x3 matrix containing the numbers that I have right here. And then you should be doing RREF on it once you get back to the main screen. And then I'm going to write the resulting matrix, and then we'll go through and we'll interpret the results. So right now, it would be a good idea to pause the video, enter this into a matrix, for example, matrix A, go back to your home screen, your main screen on your calculator after doing that, hit matrix, math, option 8 for RREF, and then go retrieve the name of the matrix where you stored this. So for example, if you stored it in matrix A on your main screen, you're going to be entering that, and then hit enter and see what you get. Once you're able to do that, then continue the video so that you can see if you got your result correctly. All right, now your resulting matrix should be as follows: 1, 0, 0, 0, 1, and 4/5. Originally, you would have gotten 0.8 there, or 8/10. If you hit math fraction on it, it'll change it to 4/5. Not that you couldn't do that on your own, but it will do it for you. All right, now we're going to go through and we're going to interpret our answer. So again, sometimes I put a little dividing line right there. What this is saying is that we have, notice that we have ones on the diagonal right here and zeros everywhere else. So this is saying 1x is equal to 0 and 1y is equal to 4/5. So our final answer for this, and we're going to write it as an ordered pair, is going to be, and I'll write it up here to save space for later, 0, 4/5. The final answer to your system, your 2x2 system here, is going to be an ordered pair. All right, in the next example, first thing we're going to do is set up our matrix. So we've got 1x minus 1y is equal to 3, -2x plus 2y is equal to -6. So that's how we're going to set up our matrix. And then we're going to do RREF on it. All right, so again, I would encourage you to pause the video, enter the information into the matrix, do RREF on that matrix, and then see what your resulting matrix is and see if it matches what I'm going to get. Your resulting matrix is 1, -1, 3, and then 0, 0, 0. All right, now, again, if we separate kind of this right-hand column over here, if you notice on this particular one, we do not have ones on the diagonal and zeros everywhere else. All right, so that means we've got a special scenario. So when we have a special scenario, we are going to hone in on this last row right here, and we're going to interpret that. And if we interpret that, it says 0x plus 0y equals 0. Or in other words, it's saying 0 is equal to 0. And we know from solving algebraically, when we get a true statement like that, our variables go away and we get a true statement like that, we're going to have infinitely many solutions. So our final answer is going to be infinitely many solutions, or infinite number of solutions, however you prefer to say it, on, and we've got a 2x2 system here, so it's going to be on a line, and we can either use the top equation up here, the bottom equation, or we can even interpret this right here. All right, and that means 1x minus 1y equals 3. In this case, it's this equation right up here. But we can use that to interpret it. So x minus y is equal to 3. That's going to be my final answer. Keep in mind, our final answers are going to be in the same format they would have been if we would have solved them algebraically. We're just using our calculator and our REF as an alternate way to solve these systems of equations. All right, in number 7, if we set up our matrix, it's going to be 1/2, -3, 1, 1, -1, 17. And again, those are coming from the coefficients for my x variable, the coefficient for my y variables, and then the constants. I'm going to do RREF on it. So again, I would enter the information into the matrix. I would do RREF on it, pause the video while you're doing this, and then check your results with mine when you're done. All right, your resulting matrix should be 1, 0, 20, 0, 1, 3. And again, we'll separate this and interpret. And if we notice in this case, we do have 1s on the diagonal and 0s everywhere else. So when we go through and we interpret that, we're going to get that x is equal to 20 and y is equal to 3, so our ordered pair answer is 20, 3. All right, and then in example number 8, if we set up our matrix, we're going to have 12, 3, 16 in our first row, -36, -9, and 32 in our second row. That's our matrix. We'll do RREF on it. Again, enter that. Try it on your own. Pause the video. Check your results. Your resulting matrix should be 1, 1/4, 0, 0, 0, 1. All right, and again, if we interpret our result, if you notice, we do not have 1s on the diagonal and 0s everywhere else. So once again, if we go to our bottom row, then we're going to interpret that. And if we interpret that, it's saying 0 is equal to 1. 0x plus 0y is equal to 1. So 0 is equal to 1. Sorry, I'm running out of space here. And we know then that if we're solving algebraically and our variables go away and we end up with a false statement like 0 equals 1, we know then that our final answer is no solution. And you can either write the words no solution or you can use the mathematical symbol for no solution. Either one is fine. You don't have to include both. All right, now before we go on to the next part, I want to say the following. A lot of times students will ask me, what do I need to write down? What do I need to do to show my work? And that's basically exactly what I've shown you right here. You need to show that you're doing RREF, that's the calculator function, on this matrix. So you need to show what that matrix is, what the values are. You can't just write RREF on A. I did that right here so you could see what was on the home screen. RREF on matrix A, you need to do RREF on this side of the matrix, okay, because we do RREF on a matrix. You need to show the contents of the matrix that came from your system of equations. You need to show what the resulting matrix is, so it's equal to the resulting matrix, and then you need to interpret that resulting matrix into your final answer. So maybe your final answer is an ordered pair. Maybe it's infinitely many solutions on a line. Maybe it's no solution. But those are the components that you need to show as far as your work goes. And then finally, before we get into the last part of our notes, Notice here it says, now go back and rewrite the first 4 examples as matrices, and then in numbers 2 and 3, perform row reduced echelon form, or RREF, using the calculator, and interpret your results. If you would like to go back and practice those on your own, you may. I'm not going to go back and do them because I've done 4 right here, and we've got some more things we're going to practice in the upcoming part of the lesson, but if you would like to do that, you certainly may do so. All right, now in the last part of the lesson, in numbers 9 through 14, we're going to practice writing the solutions, the final answers, in other words. If these are the matrices that you get after using our REF. So what we mean by that is we don't know what the original system of equations look like. So we don't know what our matrix looked like that we entered on the calculator. We just know that we did our REF on a matrix that represented a system of equations, and this was the resulting matrix that we got. So we're just going to practice interpreting our solutions. So I think even right now, I'm just going to go through and do my little, there's nothing obviously mathematical nor magical about these little squiggly lines, but sometimes I do that when I'm teaching it. All right, so let's go through and do our interpretation. If you notice to the left of that little squiggly line, all right, we've got 1s on the diagonal and 0s everywhere else. So that means my final answer then in this case is going to be 1x is equal to 3 and 1y is equal to 4. I'm sorry, negative 4. So I can just right away write that as my ordered pair answer. All right, on to number 10. If I look at this particular example, I do not have 1s on the diagonal and 0s everywhere else, so I'm going to go to this final row and I'm going to interpret that. That is saying 0 is equal to 0. All right, 0 is equal to 0. And when that's the case, I don't have any variables, but I have a true statement. That's when I have the scenario of infinitely many solutions, or infinite number of solutions if you prefer, but infinitely many solutions on, and then we have to state the specific line. All right, well, you may say, well, I don't know what the equation of the line is. I wasn't given the original system. Well, we can go back and we can interpret this row right here because that will give us the equation of the line. So that equation is going to be 1x minus 2y is equal to 3. So infinitely many solutions on that particular line. All right, next example. If we take a look, we do not have 1s on the diagonal and 0s everywhere else. And again, when I'm referring to that, I'm talking about this left-hand side, anything to the left of that green squiggly line. All right, so if I don't have 1s on the diagonal and 0s everywhere else, I'm going to go to the bottom row and I'm going to interpret it. And that bottom row says 0 is equal to 1. So our variables went away, and we have a false statement in this case. So my final answer is going to be no solution. Or the words, if you prefer. All right, at number 12, I've got a larger system, a larger matrix, larger system. But if you notice, I have 1s on the diagonal and 0s everywhere else. So when I go to interpret this, I'm going to get that x is going to be equal to 2, y is going to be equal to 3, and z is going to be equal to 4. I've got an ordered triple. And that's going to come from this right here. It says 1x is equal to 2, 1y is equal to 3, 1z is equal to 4. All right, now when I'm teaching this live in class, I usually do number 14 and then I come back to number 13, so I might as well do it that way. If we take a look at number 14, we do not have 1s on the diagonal and 0s everywhere else. So once again, though, we're going to go to this bottom row and we're going to interpret it. This is saying 0x plus 0y plus 0z, or in other words, 0 is equal to 1. And 0 is equal to 1 is a false statement. So once again, I have no solution. You can use the words or you can use the mathematical symbol for no solution. And it doesn't matter how large my matrix slash system of equations is, if I end up with a 0 equals 1 scenario, a false statement in this case, it's gonna be no solution. So we're still just gonna go to that bottom row and interpret it if we don't have ones on the diagonal and zeros everywhere else. All right, and then going back to number 13, if you look, we do not have ones on the diagonal and zeros everywhere else. So once again, we're going to go to our final row and we're going to interpret it. And when we interpret that, that's saying 0 equals 0. So we know that's an infinitely many solutions scenario, or infinite number of solutions if you prefer to say it that way. So it's going to be infinitely many solutions on, now here's the thing, we've got a 3 by 3 system here, and so instead of it being infinitely many solutions on a line like it is in a 2 by 2 scenario, when we have a 3 by 3 scenario, it's going to be on a plane. So infinitely many solutions on the plane. Well, we need 2 lines to define a plane. So we're going to go to this first row and we're going to interpret what that's saying, and that will give us the equation of one of the lines. Then we'll go to the second row and interpret that, and that will give us the equation for the other line, and those 2 lines will form our plane. So here's what I mean by that. In the top row we have 1x, we don't have any y's, and then 1z is equal to 2. And in the second row, we have 0 x's, 1 y, plus 1 z is equal to 3. And so all of that will be necessary to write for our final answer on number 13. It is a special scenario of infinitely many solutions, but because we have a bigger system, that solution is going to be defined by a plane, and therefore we have to go to the first row to define one of the lines in that plane, and the second row to define the other line in that plane. All right, so just a couple things to wrap up. There was a lot of preliminary information at the very beginning. When we got to this second page of notes, this is what you're going to be doing in the homework. And I gave you practice on how to write the information on your paper, you know, how to write the systems information by way of a matrix, and then the functionality we're going to use on our calculator, our REF, how to write the resulting matrix, how to interpret that as far as your final answers go. So the second page is more in reality what you'll be doing in the assignments. And I did talk through how to enter the things on your calculator and what functionality you're going to be using. However, if you had any trouble with doing that on your calculator because I was just talking through it and not showing it to you, make sure you ask your teacher about that, and your teacher can go through the literal calculator steps and show you when you are in class.